is 1.5 standard deviations greater than the mean? If the mean is 140 and standard deviation is 16. That's it. So if the mean's 140 and standard deviation is 16, and you're supposed to be going greater than, are you going to be adding to the mean or subtracting from the mean?
Adding.
Better be adding. So how many standard deviations do you add? Well, you take one full step, which would put you at 156, and then you have to take a half a step, which now means you have to come back and figure out what half of your step is. And if they give you a situation like this, they're probably, the vast majority of the time, going to give you something that yields you a whole number. So they won't give you 25 and give you 12.5, but they could, but they aren't that ugly to you. Okay? So that means I have another 8 units that I'm dealing with in the problem. So now I have this 156 that I added, that 140 that I added 16 to, and I'm taking that and I'm adding the 8 to it, which puts me at a position which is going to be 164. We can draw pictures. Or we can say, from 140, I want to add 1.5 standard deviations. From 140, I intend to add 1.5 times the standard size step, which is very easy to put into the calculator. 140 plus 1.5 times that value of 16, still the same thing, 164. You have options. For the first time, you have options about the way you want to approach things. And it's up to you to decide what's going to be best for you. But there's really no reason that you would miss any of these questions. Oh, I'm not going to see questions like that. Yeah, well, you know, let's find out. Maybe you will see questions like that. Normal distributions. 22 problems. Question number 1, right off the bat. Hot dang. Looks very familiar with what we just got done doing, right?
Yeah.
Need to draw pictures? You can. Can you do it by looking at just distances and the numbers? Your choice. Is that one you're going to miss? God, I hope not. Okay? Oh, well, that was too easy. The rest is going to be harder. No, it's not. No, it's not. Only now, this maybe is encouraging us a little bit more to look at the number side rather than drawing pictures. So if I have a mean that's at 100 and I'm at 125.3, I know that I have 25.3 units of distance between where I started and where I ended. That's that many units. And that is what part of a standard step? Well, gee, that shouldn't be a massively difficult problem, because now I'm taking that 25.3 and I'm dividing it by 10. And the z-score that I'm going to have, the standard score, the number of standard deviations is 2.53. Notice they told you to type an integer or a decimal. They didn't mention rounding off, did they? Because you don't need to. Therefore, don't. I tried to explain that to someone in the lab yesterday. They were rounding off. They kept saying, well, I don't want to. They didn't say 2 decimal places. Why can't I use 1? Well, you can as long as you want to keep getting it wrong. And I walked away. Okay? Been there, done that. Different type of question. Now look what you've been given. Women's heights average 66 inches with a standard deviation of 2.6 inches in a certain study. Use the 68, 95, 99.7 rule. They will not mention that phrase unless it's a normal distribution, because it's only applicable to a normal distribution. To find out what the endpoints of the middle 99.7% are. So the typical difficult question that I have to ask you is, I didn't want to do that. I'm in question number 4. Was it 4 or was it 5? Yeah, it was 4. I meant to go big there, okay? The typical question I ask is, where's your center? And what's your size of your standard step?
90.
And you're looking for what standard deviation is associated with 99.7%. That you have to encapsulate in your brain. 3 standard deviations. That's plus or minus 3. So now you're looking at, I need to take 1 step, 2 steps, 3 steps back to get the small value. I need to take 1 step, 2 step, 3 steps forward to get the large value. You may do it 1 step at a time and say, I'm adding 2.6 and get 68.6. I'm adding another 2.6, coming up with 71.2. I'm adding another 2.6 to that, coming up with 73.8. And then going back here and saying, this value is going to be 73.8. And then you can do the same thing with subtraction. You can come back here and say, well, this is going to be 2.6 smaller, so now I'm at 63.4. And then I take a 2.6 away from that, and that's going to give me a 60.8. And then I take a 2.6 away from that, and that's going to leave me with 58.2. And that's the number that you're going to put inside here. Or you're going to do 66 minus 3 groups of 2.6 to get there. Or you're going to do 66 plus 3 groups of 2.6 to get there. I don't know what you're going to do, but I, by golly, am going to be pretty certain you should be able to get to the right answer. Now, assuming my arithmetic was good today because I did not use a calculator on any of this nonsense, those values better be the right answer. So obviously my arithmetic